Hi everyone, my name is Matt Williams. I'm a tutor in politics here at Jesus College at the University of Oxford. But today I'm going to talk you through a past Oxford interview question for computer science. Jesus College is very powerful in computer science because, amongst our many distinctions, our head of the college, Sir Nigel Shadbolt, is a professor of computer science. Anyway, let me talk you through the question. It's quite complicated, so you'll have to bear with me for a second. What I want you to imagine is that there are 7 pirates, okay, and they are ranked by order of seniority, A, B, C, D, E, F, and G. Pirate A, let's call them the captain, is the most senior pirate. And the most senior pirate has to divide up the bounty of treasure that they have found. They've got 100 gold coins. They're not divisible gold coins, they're singular gold coins, okay? What the senior pirate, the captain, has to do is to determine the optimal division of those gold coins amongst the 7 pirates and then call for a vote. And what needs to happen next is that half or more of the pirates vote in favour of the proposed division. If the captain gets sufficient number of votes, then it stands. If not, then the senior pirate, the captain, gets thrown overboard and every pirate gets promoted up a rank, so B to A, C to B and so on. And then the new captain proposes a division of the 100 gold coins, okay? So the question is, what is the optimal proposal distribution of the 100 gold coins that the captain will make when there are 7 pirates on board the ship? Okay, so you might want to pause it, have a think about the problem for a little bit, okay, and then maybe restart the video in a second. Okay, now what would usually happen in an interview is that we would just ask you to start with your honest reflections on this. Honest meaning, what do you think is the solution to this puzzle? So just think out loud is absolutely fine, indeed ideal. And then the tutors will help you towards the solution. They're not expecting you to solve this puzzle entirely on your own. So a common start to an interview question like this would involve students thinking about some way that you could divide 100 by 7. Now clearly that's problematic because 100 doesn't neatly divide by 7. So then students tend to start to gravitate towards a distribution of the coins that they think is fair, okay? Now, the issue is that these are not fair-minded pirates, so they're trying to work out the optimal division of the coins, okay? So this is a question that's trying to gauge your intuitions about decision theory and game theory. So what we're not particularly interested in is justice, okay? So don't get too hung up on what you think is the fairest division of the coins, because that's not how computers think, that's not how other aspects of the world operate. So what we're trying to work out is optimization, all right? So, okay, so we can't necessarily try and work out a neat mathematical division of 100 gold coins amongst 7 pirates. And it's all looking a bit complicated. So what the tutors will likely do is they'll encourage you to simplify the puzzle down. So they might say, well, let's not work out what the solution would be with 7 pirates. Let's just start with 2 pirates. Let's say you've got 2 pirates, A and B, one senior, one junior, and they've got 100 gold coins. What division of the coins would the captain propose now? Remember that the captain needs to get half or more votes for the proposal to stand. So the senior pirate's just going to say, well, I'll keep all 100 gold coins, thanks very much, because I constitute half of the votes, so if I vote in favour of it, it stands and that's that. So my proposal is I keep everything, let's vote, okay, and it passes, easy. So that's 2 pirates. The captain gets all 100 gold coins. What about 3 pirates? Now you've got A, B and C. What happens now? Well, with 3 pirates, it's a bit tricky because the captain can no longer assure themselves with their own vote that they will obtain the necessary half of the votes required. So what they need to do is bribe another pirate with something sufficient to secure their vote. Now, what is sufficient? Well, let's say the captain, Pirate A, needs to think about what will happen if they get thrown overboard and everyone gets promoted up a rank. Well, if they get thrown overboard, then we're back down to the 2 pirate scenario, aren't we? And in the 2 pirate scenario, the optimal solution is that the captain takes all the booty, takes all the 100 gold coins. So all the captain in a 3 pirate situation needs to think about is offering something that's better than nothing. And of course, something better than nothing is 1 gold coin. So Pirate A has to offer 1 gold coin to the most junior pirate, to Pirate C, because that's the pirate that if the captain gets thrown overboard will become the junior pirate in the two-pirate scenario and will therefore get nothing. So something is better than nothing, and therefore in a three-pirate situation, the senior pirate will offer just a solitary gold coin to the most junior pirate and will keep the 99 remaining coins for themselves. Okay, and as we keep going and increase the number of pirates, the same logic will apply. So the solution for the 7-pirate scenario is that the most senior pirate, the captain, will propose that they keep 97 gold coins and will offer a solitary gold coin to every other pirate going down the list. So 97 for Pirate A, and then 1 gold coin for Pirate C, Pirate E, and Pirate G. Because in any other situation, the votes will whittle them all the way down back to the 2-pirate scenario when someone will get nothing, unless they accept 1 gold coin. So that's the solution. It counters our intuitions because we're typically quite fair-minded species, so we're tempted to think about how can we distribute the gold coins fairly. But this, as I mentioned, is an example of decision theory, where we're trying to work out how to optimize particular decisions and processes that might happen within a computer. And so things like fairness don't really enter into it. The way to succeed in an interview question like this is to just work with the tutors. Just think out loud, show you're working, but through your words. They will try and help you. The tutors want you to succeed, so they will be cooperative and they will try and help you. You just need to give them enough to work with, so you need to speak out loud and share your thoughts, okay? You also need to suspend disbelief, because of course this is a very unrealistic scenario. And that's okay. This is an analogy, this is a thought experiment. It's not meant to be realistic. So don't get too hung up on whether or not pirates would actually behave in this way, because of course they wouldn't. But computers might. So that's why you're being asked this question. Okay? Tell me what you thought about this in the comments. Let me know if you would like any particular subjects to be covered. Thank you so much for watching. All the best. Bye now.